Hi everyone, today we're going to be learning how to solve quadratics using square roots or radicals. So we've learned how to solve graphically, we've learned how to solve by factoring, and when those two methods don't work, we also have a third method of solving with square roots. So real quick, we're going to do a quick intro of how to solve this graphically one more time. So we have the equation x squared minus 5 equals 0. We're going to solve it graphically, so go ahead and grab out your graphing calculators and let's go to our graphing calculators. We're going to go to our y equals. All right, we're going to type in that equation x squared minus 5. And graphic. So it looks something like this. So we need to find both of those zeros or roots. So I'm going to go over to this first one here. Remember to do this graphically. We're going to do second trace. I'm going to go down to the word 0. It's going to ask us a series of questions and say, is it left bound? You want to move your little cursor to the left of that first 0 and then push enter. It's going to ask you to go to the right of it. So now I move that little cursor to the right of it and push enter. On your calculator, it's going to say guess. You're going to move it so it's right on top of it and push enter. So my first 0 here, if you look, is negative 2.236. We're going to repeat that process. For the other zeros, you're going to move your cursor over so it's to the left of it, push enter. Move it so it's on the right of it, push enter. For yours, it's going to probably say guess. So move it so it's right on top of the root and then push enter. So this one over here is positive 2.236. So I'm going to draw it into my notes real quick so I have a visual of that. So I had one root right here, and that first root was at negative 2.236. And I had another root right here, which was at positive 2.236. So my solutions were positive and negative 2.236. Okay. Now, those aren't the exact answers there because I did round, or I stopped that continuing equation there. So what I want us to do here is I actually want us to find the exact root. So no rounding involved, no stopping those decimals. I want to know what the exact solution would be. To find this, we're going to solve it using those square roots. If I do x squared minus 5 equals 0. I'm going to try to get that x squared completely by itself, so I'm going to add that 5 over. And then my goal is to solve for x. We'll get x by itself. To get rid of that x squared, you take the square root of both sides. The square root of x squared is just x. When you take the square root number, you're going to have the positive and the negative option of it, the square root of 5. Square root of 5 cannot be reduced. All right, so this would be your final answer here. So this is what we would call the exact solution. And up here, this is what we would call the approximate. Because we did round to get those decimals. So when I ask you for the exact answer, I'm looking for something that has a radical in it still. All right, if I'm looking for approximate, you can go ahead and solve that graphically and curtail that answer to 3 decimal spots. So let's practice a little bit more. My first example here is 2x squared plus 5 equals 41 minus x squared. So just like we did with factoring, you want to set things, so you want to combine like terms here. So what we're going to do here is I see 2x squared and negative x squared. So I'm going to add that x squared over. And I'm going to subtract that 5 over as well. So I've got 3x squared equals 36. I'm going to divide both sides by 3. So I get x squared equals 12. To get rid of that squared, remember, we take the square root of both sides. So I've got x equals the positive or the negative answer of radical 12. Let's think, can we simplify radical 12? Yeah, we know that square root of 12 can be broken down to the square root of 4 times the square root of 3. We know that the square root of 4 can be broken down to 2. So my answer would be x equals the positive or the negative answer of 2 radical 3. So we will do this method when there's no middle term. So in our quadratics, usually we have three terms. All right, we have the x squared term, the b term, and your constant term. Here we only had things with x squares. We only have those constant terms. So when you see no middle term, no variables, just an x, all right, we do this method here. The next example is the quantity x minus 4 squared plus 3 equals 11. This is what I would call vertex form. So when it's in vertex form, or in other words, when you see x minus your h squared, you're going to be doing this method. So what we're going to do first is we're going to get that parenthesis all by itself. So I'm going to subtract 3 to both sides. Then I'm going to get rid of that square. To get rid of that square, you take the square root of both sides. The square root of x minus 4 squared is just x minus 4. Plus or minus the square root of 8. Let's reduce down the square root of 8 real quick. I know that the square root of 8 breaks down into radical 4 times radical 2. And I know that the square root of 4 is 2. So my answer is 2 radical 2 there. The x still isn't by itself, so I'm going to add that 4 over. Okay. I don't combine those because 4 and 2 radical 2, they're not like terms that don't have the same radical there. You do typically put the constant without anything on it in front. So this would be my final answer. And this is what I would consider that exact solution. If I asked you for the approximate, what we're going to do is we're going to go to our calculator and we're going to type in both things. The first thing we're going to type in is 4 plus 2 radical 2. And then the second thing we're going to type in is 4 minus 2 radical 2. So let's just practice that real quick. So in our calculator, so we're just going to go to the home screen. I'm going to type in 4 plus 2 radical 2. That gives me 6.828. I'm going to type in 4 minus 2 radical 2. And that gives me 1.171. So I can write in those approximate answers there. And that is what we would consider the approximate solutions.